This is section 11.2, families of quadratic functions. Okay, so last section we were talking about parabolas, which are basically our U-shaped graphs here, and we know that those have to be of the form y equals and then x squared. We know we can have some other stuff there, like, plus 2x or plus, 1 or something like that. We know we can have some other stuff there, but the important thing is we're working with x to the power of 2. So y equals x to the power of 2 is kind of our base and what we build off of. So what we're going to talk about is families of quadratic functions. So we've talked a little bit about families before when we were talking about, like linear equations back in chapter 7, which I know that's been a while ago, but families all share something. Okay, so like our families we talked about before had like the same slope or the same y-intercept or something like that. These are also going to be sharing something. So the first picture would be families because they're sharing the same vertex. Okay, so you can see here the green one, the pink one, and the orange one are all meeting at that common bottom spot there, and that's where they all curve. That's all their minimums. Okay, now you could also have one going that way. That's a horrible line there. You could also have one going that way where it's the top or the maximum would be that same point there. But those would all be a family because they all have the same vertex. Their high and low is all at the same exact spot. Another type of family would be sharing the same axis of symmetry. So these here don't necessarily have the same vertex like the original ones, but these ones are all being split over the middle there. So it could be facing upwards, it could be facing downwards, but no matter what, they're all being split down the middle by that line there, x is equal to -5. Okay, so those all share the same axis of symmetry. I think this one is the hardest one to pick out. This one is have the same shape. So basically what you almost have to do is see how much they're going up by from point to point. So like this orange one here, to go from my bottom point to the next one, I'm going over 1, up 1, and then the next one would be over 1 and then up 3 from that. Here it's following the same thing, over 1, up 1, and then over 1, up 3. And then same for this one here. So you almost kind of have to look at the actual points and see how much you're going up for each one. And since it's quadratic, they're all going to be going by something different. But if you can look and go, okay, over 1, up 1, over 1, up 3, and it's following that same thing for each of them, then that would have the same shape. It could be facing downwards and still have the same shape. But like I said, those ones are usually the hardest to pick out from like a picture of graphs. Okay, so let's do some comparing. So what they're going to want us to do is they're going to want us to take and graph some quadratic equations here. So the first one I've got is y is equal to -x squared. So I'm going to graph that one here. And then the other one is y is equal to -2x squared. And I'm going to graph that, or I'm going to figure out my coordinates with that, and then I'll graph them below. Okay, so with these, there is no b on this, so if there's no b, I'm not going to have a different axis of symmetry, so what I can do is I can just use my normal points of -2, -1, 0, 1, and 2. If you ever have like y equals, and then you got your x squared, and then you've got something with the x, or an x by itself here, that's when you're going to have to come up with different points besides these ones. But since we don't have that for either of those, we can just use the regular points. Alright, so if we do that here, this would be, if I plug in, I got negative, my x is -2, and I square it. So when I solve that out to figure out what my y is, that would be -2 squared is 4, and then times the negative would be a -4. So my ordered pair would be -2, -4. Next one here, same thing. So I got my negative out front, parentheses -1 squared. So if I take -1 and square it, I get 1 times my negative would be -1. So my ordered pair is -1, -1, getting the x from this column, the y from what I solved out and got. Plug in 0, my favorite one. 0 squared 0 times the negative, still 0. So 0, 0. Plug in the 1, so negative and then 1 squared, and the 1's in parentheses, so 1 squared is 1, times the negative is negative 1. So this would be 1, negative 1, 1 from here, negative 1 from there. Then the last one I'm going to plug in is the 2. So that would be 2 squared is 4, times the negative would be negative 4. So my ordered pair there would be 2 and negative 4. Okay, so let's graph that one while it's fresh in our brains here. So I'm going to do this one in red. So my ordered pairs there, I've got negative 2, negative 4, so that would be left 2, down 4. Next one I've got is negative 1, negative 1, so left 1, down 1, 0, 0, and then 1, negative 1, right 1, down 1, and 2, negative 4, right 2, down 4. I'll draw my lines in there. Okay, so that is my first one. The red is y is equal to, maybe I write it here, y is equal to negative x squared. Okay, the negative is what makes it flip downwards versus upwards. Okay, so then my next one here, I'm going to use my same points. So I'm going to go negative 2, negative 1, 0, 1, and 2. And I'm going to do the same thing where I, plug in and solve out. Again, since it's a negative in front of our x squared, so this time negative 2, it's still going to be facing downwards because they both have the negative. So it's just going to be a downwards one again, and then we're going to have to compare what else is going on with these. Alright, so if I plug in, I've got negative 2. For my x, I'm going to plug in a negative 2. Make sure those negatives are in parentheses when you square them. So negative 2 squared is 4, times negative 2 would be negative 8. So my ordered pair there would be negative 2, negative 8. Next one I'm going to plug in negative 1, so I'll have negative 2, and then I've got negative 1 squared. So if I take negative 1 and square it, that's 1, times the negative 2 would be negative 2. So that would be negative 1, negative 2 for my ordered pair. Plug in the 0, the one that I like. 0 squared 0, times the negative 2 is 0. 0, 0. Plug in my 1. So 1 squared would be 1, times negative 2 is negative 2. So I've got 1, negative 2. And then the last one, plug in a 2. 2 squared is 4, times the negative 2 would be negative 8. So 2, negative 8. Okay, and then this one, I'll graph this one in blue. So my y is equal to negative 2x squared. I'm going to do it in the blue here. So I've got the points negative 2, negative 8, so left 2, down 8. Negative 1, negative 2, left 1, down 2. 0, 0. And then 1, 2, which would be right 1, down 2. And 2, negative 8, right 2, down 8. Okay, so then I draw those lines in. Okay, so then now what they want us to do is they want us to compare and contrast these. So figure out what's the same and what's different. So one thing that we talked about before is both of these graphs open downwards because they both had negative numbers in front of our x squared. So that's something we could say. So both graphs open downward. Another thing that they have in common is they both have a vertex or a maximum point at 0, 0. So we could also say vertex 0, 0 for both of them. Okay, so that's what's the same about them, but there's also something that's different about them, right? Because if there was nothing different, they'd be exactly the same graph. So what I would say for the difference here is if you look at this red one, you can tell that that one's slightly wider than the blue one. Okay, so you could say a red one here, which is y is equal to negative x squared. So you could say y is equal to negative x squared is wider than the other one, which would be y is equal to negative 2x squared, the blue one. You could also say it the other way. You could say that the blue one is narrower than the red one. Either way would be fine with that, but that's kind of what's different about them for our contrast part. Alright, next one here, the same thing. So we're coming up with both of those graphs. So here again, if we look, we don't have a b for either of those. This one has a +4, but it's not with the x value, so we can just use our normal points here. So -2, -1, 0, 1, and 2. Same with this one. Alright, so we're going to do our plugging in again. So actually this one, I think this is the same exact one we had before, isn't it? Yeah, this is actually the same exact one we had for this first one here. So really I'm just going to take those points and copy them down. So I'm going to go -4, -1, 0, -1, -4. So what was it? -4, -1, 0, -1, -4. Now, if you didn't have that, you could do the same plugging in like we just did, but it would be exactly the same as what we just did on the last one. So it would be -2 squared would be 4 times the negative, and so on. So our ordered pairs here are actually going to be exactly the same, which is very convenient because it's going to save us some time. I'll write those ordered pairs in. And it won't always happen that way. It was just kind of luck on this. Okay, so we've got that, and then let's graph them while we're at it. So I'm going to do, in red, I'm going to do y equals -x squared. So I've got -2, -4, -1, -1, 0, 0, 1, -1, and 2, -4. And it should look exactly the same as the graph we just did on the other page because it's the same exact equation. Okay, now the one that's different here is the -x squared plus 4. We didn't have that before. We multiplied by 2 last time. Okay, so let's look here. So if we do the same thing where we plug in, we've got negative, and then our x value is -2 squared plus 4. So if I take -2 and square it, that would be 4, times the negative would be -4, and then if I add 4 to that, that would be 0. So this ordered pair would be -2, 0. Next one, I got -1 plugged in there, plus my 4, so -1 squared would be 1, times the negative would be -1, plus 4 would be 3. So -1, 3, 0, my favorite one to do. So 0 squared is 0, times negative, still 0, plus 4 is 4. So 0, 4. What else we got? So negative times our 1 squared, plus 4, 1 squared 1, times the negative, -1, plus 4 would be 3. So 1, 3. And then the last one there, the 2. So 2 squared would be 4, times the negative, -4, plus 4 would be 0. And you can again see how it's developing that pattern because we used our vertex as our middle point. Alright, so this one's going to be my blue one here. So y equals -1/2 plus 4, or not 1/2, -x squared plus 4. So I'm going to graph those points here in blue. So -2, 0, so left 2, up 0, so right on the line. And then we've got -1, 3, so left 1, up 3. 0, 4, so over 0, up 4. 1, 3, right 1, up 3. 2, 0, right 2, up 0. Just draw our lines in there. Okay, so now, same thing, we want to compare and contrast these. So one thing that's the same again with these is they both have negatives in front of that x squared value, so these are both opening downwards. So you could say both open downwards. Another thing that's the same about these is they have the same shape. So they're basically going up at the same steepness each time. So you go over 1, or 1 and 1 there, 1 and 1 there, then you go over 1 and 3, over 1 and 3. Same thing is happening here, so you could also say same shape. Now the things that are different here, another thing we could say is they also have the same axis of symmetry. That would be something else we could say. So same axis of symmetry. which in this case would be the y-axis, is splitting it. Okay, now let's talk about the differences here. So one difference is we've got different vertexes, right? So this one has a maximum point right there. This one has a maximum point right there. So we could say different vertexes. And typically when you talk about the vertexes, it's spelled like that. It's probably actually vertices. That's not right. I don't know how to spell it. C's. Something like that. But vertex is fine. So different vertices or different vertexes. So a lot of times when you talk about the vertices, you actually want to write what they are in. So the one has 0, 0, and then the other one is 0, 4. So a lot of times you want to put those in and sometimes they'll actually ask for that too. I don't know if that was in the direction of these, but a lot of times they'll actually specifically ask what the vertices are. Okay, so we got that. Now what we can also do is we can describe our movement to get from one to the other. So like say we started with the red one and we were going to the blue one. Basically all we did there was we took the red one and slid it up 4 units and we got the blue one. We didn't change how like wide or narrow it was. We didn't, flip it from going down to going up. All we did was slid it up. So you could also say y equals negative x squared, which is our red one, is slid up. We could go 4 units to y equals negative x squared plus 4. And the reason that happens is because we've got that plus 4 there. So the only difference between our original equation and then the second one that we did was that plus 4 part, which would slide that up 4. If it was minus 4 there, it would take that graph and it would slide it down 4. Okay, so anytime you see that plus, just a constant value like that, it's going to slide that graph up or down. All right, try another one here. Ooh, parent graph. Okay, so what the parent graph is it's the simplest form of the graph. And we talked about this before, where it was in the most simple form possible. And this should actually be positive x squared. So our parent graph is always going to be y equals x squared, and that's the simplest form of the graph, the one that they use the most common. So it's probably not a bad idea to have these ordered pairs just kind of already written in here. Because we use this one so much, it's probably not a bad idea just to have that one in your notes that says parent graph with it, because they make a lot of references to it. So we can graph it here as well, and it's going to use these ordered pairs here. So negative 2, positive 4. Negative 1, 1, 0, 0, 1, 1, and 2, 4. So that is called the parent graph, and it's the simplest form of one of these quadratic equations. Okay? Alright, so now what they're going to do is they're going to ask us to compare to the parent graph. Okay, so it might not be a bad idea to actually graph the parent graph on this. So like I said, it's nice to have those ordered pairs already written so you don't have to make the table out this time. I've made it so many times I just know it off the top of my head. So for our parent graph, we got 0, 0, 1, 1, 2, 4, 3, 9 if you want to keep going up that far. And then negative 1, 1, negative 2, 4, negative 3, 9. But again, oops, that was a horrible line. Just use those points from that table on the other page, and that will be your parent graph. So now what we want to do is we want to compare how this graph here, this equation, changes from this parent graph. So it's going to, do something, whether it, slides up or down, right and left, gets bigger, gets smaller. It's going to do something, and we have to describe what's happening. And then it also says there, name our vertex. So that's kind of what I was talking about before, that a lot of times they'll ask you to name the vertex. Alright, so situation like this, we don't have a B in this case. We've got an A and we've got a C, but we don't have a B, so we can use our normal points. So negative 2, negative 1, 0, 1, and 2. Plug those values in to figure out our Y. So we'll have 2, our x value is negative 2 squared plus 1. Negative 2 squared would be 4, times 2 would be 8, plus 1 would be 9. So negative 2, 9. Plug in our negative 1. So negative 1 squared is 1 times 2 is 2 plus 1 is 3. So negative 1, 3. Plug in our 0. 2 times 0 squared plus 1. All of that, when you do it out, is going to be 0 plus 1 would be 1. So 0, 1. And then next thing there is 1. So 2 times 1 squared plus 1. 1 squared would be 1 times 2 is 2 plus 1 is 3. So 1, 3. And then 2. 2 squared plus 1. 2 squared is 4 times 2 is 8 plus 1 is 9. So 2, 9. Alright, now let's graph this one. So first thing we got there is negative 2, 9. So left 2 up 9. Then we've got negative 1, 3. So left 1 up 3. 0, 1 over 0 up 1. 1, 3, right 1 up 3. And then 2, 9, right 2 up 9. Graph that, draw those lines in. Okay, so comparing that to our parent graph, which is the one in black there, I can tell a couple things. One thing I can tell is that it doesn't share the same vertex, right? Because this one is at 0, 0. This one, our low point is slid up 1. So we could say our vertex, in this case, is at, we'd go over 0 and up 1. So 0, 1 is our vertex in this case. So how this kind of compares to or changes from the parent graph is we slid it up 1, right? So you could say up 1 unit or slid up 1, something like that. And then something else also happens here. It is also narrowing. Now I can tell that it's narrowing from the parent graph because if I look from, my vertex going up, I went over 1 and up 1. And then with this one here, I went over 1 and up 2. So I'm going up at different intervals there. So that means that they're not the same shape. So you could say that it's also narrowing, or it narrows from the parent graph. And we're always comparing it to that same parent graph there of y equals x squared. All right. One more here. Alright, so again we want to compare to the parent graph, so I'm going to graph that one in again in black. Again, using those points from the previous page. So we got 0, 0, 1, 1, 2, 4, 3, 9, negative 1, 1, negative 2, 4, negative 3, 9. Draw that in there. And that is our parent graph. Okay, so now we want to do our new graph here, y equals, and then we got parentheses here, x plus 1, and then our squared minus 5. Okay, so I'm going to use my regular points, negative 2, negative 1, 0, 1, and 2. Alright, so when I plug in here, I'm going to go parentheses, negative 2 plus 1, so my x is going to be the negative 2 in this case, squared minus 5. Okay, so negative 2 plus 1 is negative 1. Now I square it, so now it's negative 1 squared, which is 1, minus 5 is negative 4, so you're just solving out what's in parentheses first. So negative 2 plus 1 is negative 1. Then when I go to square that, that's how I get the 1, and then 1 minus 5 is negative 4. So I'd have negative 2, negative 4. Next one, same thing. I'm going to go negative 1 plus 1 squared minus 5. Negative 1 plus 1 is 0. Squared is 0. Minus 5 is negative 5. So negative 1, negative 5. Next one is 0. So 0 plus 1 squared minus 5. 0 plus 1 is 1. To the power of 2 would be 1. Minus 5 is negative 4. Next one here, oops, I should write that 0, negative 4. Next one would be 1 in there, so 1 plus 1 squared minus 5. 1 plus 1 is 2. Squared would be 4, minus 5 would be negative 1. So 1, negative 1. And then last one, 2 plus 1, squared minus 5. 2 plus 1 is 3. Squared is 9, minus 5 is 4. So it would be 2, 4 for that ordered pair. Now, you might be wondering why this one's not following a pattern. The reason this one's not following a pattern is because the middle one we had here is not actually our vertex, because we've got other business going on with our X. It's kind of like thinking we have a B, but in this case it's kind of hard to figure out what the B actually is, but we do have a B value where we'd have an X by itself, but it's kind of a lot of work to get to that, so it's okay just using those points, and I'll kind of show you what it'll look like. So our ordered pairs there, negative 2, negative 4, so left 2, down 4, negative 1, negative 5, left 1, down 5, 0, 4, so over 0, down 4, 1, negative 1, right 1, down 1, and then 2, 4, so right 2, up 4. So now you can kind of see here that I kind of have a U shape where it's kind of going like that, but I'm kind of missing this other side of this. We know that it's going to bottom out right here, so I can just kind of take that and keep it going that way. That'll happen. It won't look the same on both sides. If your vertex isn't the middle one there, it's okay. Just kind of draw those lines in the best that you can. It'll just keep following that shape. Alright, so some things about this one. We can talk about our vertex first. So our vertex of this one, our bottom point here, would be at negative 1, negative 5. So our vertex is at negative 1, negative 5. And then to get from the black one, the parent graph, to the red one, basically to go from 0, 0 to negative 1, negative 5, we are going left 1 and down 5. So our movement here is left 1 and down 5. Okay, and that comes from these numbers up here. It's going to keep the same shape because we're going over 1 and up 1 on both of those. So you wouldn't have to say anything about narrowing or widening. Okay, so I know that's a lot, but that is the end of this section. So for your assignment, you got 466, 10 to 24 even, and it would be wise if you did this on graph paper if you have any.